Perfect.
Okay. Should I go over that again?
No, I think that's great.
All right. So first, do you want to introduce the?
Yes. Hello, everybody. Julie again. I have a single slide. It's just a program announcement. Should be 1 minute or less unless you have questions. So if you could go to the next. We just would like to announce that the Source Protection Loan Program is now live. If you want to bring this to any of your clients or you have projects that this might be of interest. This is a new funding opportunity for municipal public community systems, and this includes fire districts, to purchase land or conservation easements to protect existing or future water supplies. So this could be used to develop a new water supply. The funding is 50% grant, 50% loan, and it's intended to do a few different things or a combination thereof. Helping systems achieve control of their 200-foot isolation zone around the wellhead, develop a new source if they need to address a deficiency in quantity or quality of water, and then possibly securing additional land around their source protection area, like outside of that 200-foot isolation zone. And I realize you might not be able to click on this link here, but we do have, it's an online application. It's just like a very simple PDF, although there are requirements within that PDF of what the town needs to do, and a fact sheet, and I am the contact. All that information is listed on the website. So we just wanted to announce that in case you have clients that are interested in this.
Yeah, and we'll send a summary out at the end, so you don't need to scramble to write this down or anything.
Yes.
So are you saying that a municipality that needs to, for whatever reason, develop a new source, this could be used for that?
Yes.
There are
So
conditions or
they're just kind of like eligibility criteria of the way that we're going to score the applications. So like achieving control of their isolation zone gives you so many points. If you need to address a deficiency in quality or quantity, that's so many points. If you need to secure additional lands, etc. And so it's like, it's just going to be, there's 3 application periods a year. And if we get more than one application in that time period, we'll just rank them based on their eligibility. And that is in the application packet. So yes, it could be used.
what does the funding look like for this? Like how much?
We currently have 500,000 set aside. And then in this year or last year's IUP, the set aside number was reduced because the legislator was earmarking a lot more of the money. So we decided not to, because we hadn't rolled out this program yet, we decided not to put more money into the program. But the idea is that we'll potentially be able to put more money in. But we'll start here, see where it takes us, see what the interest is. Historically, it's been available, but just not at a 50% loan, 50% grant level. And we heard that that was not interesting enough to water systems. And we're hoping that maybe this 50% will make it more interesting, but we'll see, and then see what the funds over time will need.
The 20-year repayment at 0%. No administrative fee. That's it for me.
Do you have any questions from the online folks about this before we move on? All right. If you do, feel free to drop them in the chat or just raise your hand and chime in. All right.
I'm Erin Stewart. I'm, as I said earlier, a hydrogeologist doing source water permitting. So I wanted to talk today, and should I stand up? Can people see me on video? Yeah, I can stand.
Okay.
And just like, I know I feel weird when like I'm in a blind spot there.
Yeah,
You can see me, and I'm going to talk a little bit longer than Julia, although this is a blind spot too.
Yeah.
The library
Live thing. I don't know.
Now we can see you.
Yeah,
On the
okay.
screen too.
So I'm just gonna stand, I'll stand behind you. Okay, so I'm gonna talk a little bit about reduction in average day demand. I'm gonna do an overview of how ADD and MDD, I'll probably use those, everyone's familiar with those, are calculated based on the water supply rule, and then how we reduce ADD through a meter data study. So the reason we wanted to talk about it with the engineers is because we see a lot of systems, we've seen a lot the past year, mostly NTNCs coming in to reduce their ADD through a source permit meter data study. And there's confusion on how to do it because of the way the water supply rule is set up. So we don't get this a lot with the hydrogeology consultants. We get a lot with the engineers. I think because it doesn't really involve hydrogeology work. No one's going out and drilling a well. No one's doing a pump test. Okay, next slide, Sienna. All right. Well, I guess I just said all this. Sorry.
So next one.
Next slide. Oh, then I'll talk a little bit about what ADD and MDD are used for after the source permitting process and how they're influenced in the permit to operate and construction permits. Okay, next slide. So I'm sure we all know this. I don't have to talk about it very long. Community water systems use table A2-1 for calculating ADD. You sum up the uses, you have an average day demand. And then from that, you use a peaking factor of 2, and you divide by 24 hours a day to get your maximum day demand. So that's for community water systems. For non-community water systems, our NTNCs and TNCs, you also use table A2-1. And then to get average day demand, we divide by 720 minutes. We don't use a peaking factor. Next slide, unless there's questions. We can always wrap after there are questions. So after the source permit, what those numbers mean down the line are different based on whether community or non-community. Both communities and NTNCs are required to have average day demand of storage. So this is one of the reasons we see some NTNCs come into us to try to reduce their MDD because they don't have room for the amount of storage required based on the ADD calculated through the rule. They know through historical monthly operating reports, or maybe they have meter data collecting over the years every day that they don't use as much water as the water supply rule says. So we want to reduce it so we can have a smaller storage tank, something like that. And then MDD down the line results in what treatment is sized for. So on the other side, we've had TNCs that want to reduce how much their treatment. So they go through the process to have a smaller number so that their treatment trains, I'm not an engineer. So there's different types of treatments I might not be talking correctly are sized appropriately to the amount of water they're actually using. The other thing is for community systems, for the permit to operate, our operations section looks at if a system is using 90% of their maximum day demand, if they direct them to find a new source. So that number is important there as well. So by reducing the ADD, you can reduce the maximum day demand, which then can result in different things down the line for you, or not having to look for a new source, something like that. Next slide. Okay, so reduction in average day demand is in the water supply rule, Appendix A, Part 2, Section 2.2.1.2. And it talks about community water systems in this section because we're in Part 2. So it's based on the results of meter data. You can't reduce below 60 gallons per day per person in a residential dwelling. This can have an effect on calculations. There's a 10% leakage aging factor, which has to be added to empirically derived ADD. And then there are 4 different types of proposals that we see. We see meter readings of the existing water system. They have to be collected for a year or 6 months if you're in like if you're a TNC in a seasonal area, like a ski resort or something, and you're only open 6 months of the year, and that's the busy time. And then another one, which I haven't seen yet, is meter readings on existing similar water systems. My predecessor kind of explained one that he went through with a campground, and they use data from state parks, from multiple state parks, to kind of prove these state parks are the same size as us. This is what our ADD MDD should be. So that you still need the same amount of data, and you need more than one similar water system. So it's usually like 2. So it's still a lot of data, but that data exists out there, I think, especially with the state parks and how they operate. So then the third one, which we see almost all the time, is installation of low flow plumbing. For new things, it's just an automatic 10% reduction from table A2-1. Almost everyone applies that for new systems. And that number is already accounted for in the wastewater rules, if anyone also works in there. So we don't have that in our table A2-1, so it's another way to do that. And then we have other proposals on a case-by-case basis, which we would have to approve. Then when we go to the non-community systems down in appendix, part 11, right? They get the 10% reduction in low flow plumbing fixtures, but they have no mention of any other way to reduce their ADD. So currently we refer them back to community systems, everything I just went through. And that, because of what I already talked to, has led to some issues with how we calculate things. So my next slide is kind of an example of how we would want to see the source permit application and the data and the calculations. Is that a system comes in for the top two, they have ADD and MDD from the water supply rule. And then they have their meter data study of a year, collecting data and population depending on what type of system it is. If it's like a hotel, we want population. And then from that, you can do a ratio between the maximum day demand, the metered maximum day demand and average day demand to get a peaking factor, which then you can use to reduce the maximum day demand. So a lot of, I've seen a few over this 10% aging leakage factor seems to get dropped out. And we have to remind people to put it back in. It's a very like one line in a very long rule. But that really influences the change in the maximum day demand because it inflates the ADD a little bit. And then you're using this inflated ADD just a tiny bit to account for aging and leaking to calculate a maximum day demand. So for non-community and TNC, I guess the big point is we don't want to divide by 720, like 12 hours to get our maximum day demand. We want to divide by the whole 24 hours. So that's not what they do if they're following the table A2-1. Because it's a meter data study, they're collecting daily data over 24 hours. So that's the other thing we've seen is people getting confused about how do I divide? What do I divide by? 12 hours or 24 hours on a TNC? So yeah, that's the big point there. Any questions?
Yeah, I have a question.
Okay, yes, Dave?
Yeah, so if using a ski resort or a ski resort town as an example, what I've seen in the one I was involved with is the first quarter has a much different demand characteristic than you would use for the 12 months for the annual. And I don't know if the regulations make that distinction. Now, from an engineering standpoint, we would want to make sure that we provide sufficient supply and storage to meet that peak demand period.
Yep.
And I'm just wondering if that's defined or spelled out in the regulations.
Yeah, so the metered maximum day demand will be the highest used day of the whole year. So you'll capture that first quarter if they have the highest day in there as that metered maximum day demand.
And ADD?
ADD is the average over the whole year.
Okay.
Or abbreviated time period.
Right, exactly, or abbreviated time period, depending on, because we don't require a school to do the summer months if they're empty. Yes, Willie?
Well, when I've looked at these in engineering reports,
Mhm.
we'll also, and engineers will look at the meter data from the water system and there'll be outliers.
Yes.
And they'll want to investigate high days.
Yeah.
Yes.
And if there's some explanation, like it was we flushed hydrants that day,
Mhm.
or there was a documented leak.
Yeah.
Then we kind of remove that outlier from the MDD calculation.
Exactly, yes, yeah. That's still in there, and then if it's a residential area, you'll have If the ADD results in you're underneath the 60 gallons per day per person, you automatically have to go up to an ADD that has the 60 gallons per day per person. Right? We won't permit a metered ADD that's below that 60 gallons per day per person threshold. So that puts another calculation into this mix for community systems if it happens. Yeah.
And we also discussed, so this was first brought up, we have sort of a similar setup where we meet with all the hydrogeologists that are working as consultants doing source permitting work. And one of them brought up how he was applying this 2 standard deviation from the median and removing all of the values above and below that as a way to say these are outliers. And we would look at, if you came to us with that kind of calculation, there would need to be an explanation for why you decided to apply that kind of calculation and whether that makes sense or not. But some people would use that.
I would fall under the other proposals.
Yeah.
Anything else from the online folks?
Just a clarification for the storage requirement, meeting the ADD. I'm assuming that's usable storage. And I'm not sure that if the regs state that specifically, but it would stand to reason that would be usable storage.
That's what we'd want to see in a new design is, you're trying to provide that amount of, you need to have the average day demand storage that's possible to use. What we find when we go out to water systems is they'll have a large storage tank, but over time they'll realize they have to maintain a certain elevation in that storage tank to provide pressure. And there's no clear documentation about how much effective volume there actually is in the storage tank. So we do find that in practice, that's not always the case, but when there's, for a new tank, those are the kind of, we're looking for usable storage volume and that it's been considered.
It makes sense.
All right, if you have any other comments or thoughts on that topic, feel free to raise your hand, but otherwise we're going to move on to our next topic. Willie?
I think Allison is going to lead us through this one.
Oh, all right.
Yeah, unless I have a coughing fit or something, and then Willie is gonna take over.
Okay.
So we can go to the next slide, Sienna. Hopefully, many of you have had a chance to look at the evaluating water system hydraulics guidance that has been on our website. I'm just gonna walk through kind of the what, where, why, who, how, when, and some of the lessons we've learned looking at hydraulic evaluations that have tried to comply with this guidance. So Sienna has it up just where you can find it on our website, because we know it's not overly intuitive. So if you don't have the invitation handy and the link, that's where you would find it. The guidance is intended to clarify the expectations of the division when we require or request hydraulic evaluations for public water systems. It provides some terms and definitions, reporting and documentation requirements, and describes requirements for pressure tests, hydrant flow tests, hydraulic grade line evaluations, and hydraulic models. For models, the guidance really focuses on steady state or static, as opposed to dynamic models. We have received results from dynamic models, but it's the vast majority are steady state. So where can you find it? It's up on the screen. Who was it developed for? It was really developed for all of us. It's needed internally, especially when training new staff or trying to communicate across sections or even divisions within DEC. And it's needed externally for systems and consultants to better understand what our expectations are and what our requirements are. And why has really been because someone will say you need to do a hydraulic analysis, and you'll say, what does that mean? And it really depends on who you've asked. And so to try and not have that happen, we've developed this guidance. We want to be clearer with each other and with the systems about what a hydraulic evaluation might look like, what its limitations might be, how it might be used. And so again, that went into this. And we want to be more deliberate in what we're requiring, and only require what's needed for the situation. You know, there's a wide variation in the systems we regulate and the situations that they're in. So a condominium complex versus a multi-town water district with an expansive distribution system, or one simple pressure zone that relies on one gravity tank, right? That's gravity fed from one atmospheric tank versus 8 pumping stations. We were trying to figure out how to give you some idea of what we might expect in those various situations for those different systems. We also were seeing a wide variety in the quality of the hydraulic evaluation submitted. Not always that the work wasn't done or it was done poorly, but it wasn't communicated. So you might just get a result instead of saying, what were the boundary conditions? What are the limitations? What went into this? And what would this not be appropriate for? Because that's also where this is going to go. A board might refer back to this 5 years from now and it might not hold. And to that last bit, there are components of the guidance that are really aimed towards governing bodies of water systems, boards, prudential committees, ownership structures. The division sees a need for these governing bodies to understand the hydraulic limitations of their systems. Unfortunately, it's relatively common for systems to connect users that are outside of their service area boundary. For example, for the system that relies on one atmospheric storage tank that gravity feeds the distribution system, we see connections made very close in elevation to that storage tank. Maybe it's the farmer who gave them the land for the tank, something along those lines. They could never serve that home or those connections well, at least not meeting rule requirements. So we're trying to help systems get the information they need to make better decisions, or information data-driven decisions. How is this developed? It was developed by multiple division staff over years. We referred heavily to AWWA, M17, fire hydrants, installations, field testing, and maintenance. AWWA's M32, computer modeling of water distribution systems. Also their handbook for water system distribution, distribution system modeling calibration, as well as some other state guidance, specifically Oregon, Utah, Texas. They all have some guidance that we looked at. So the draft guidance was posted to the website in 2019. Prior to posting that, we did solicit some feedback from consultants that were working on hydraulic evaluations at that time. We received some comments then and tried to incorporate them, and have since been more widely distributing this and seeking comment. And so the other part of the when is, when do you need to apply it? When do you need to comply with this guidance? And the first page, or one of the first sections, excuse me, of the guidance tries to get at common situations where you would look at this. Construction permit applications. It really depends on the project that you're working on. For many projects, a Hayes and Williams relationship calculation to estimate available flows and pressures is probably all you need. But there are projects that are larger, more complex, like absorbing an adjacent water system or trying to address widespread pressure deficiencies, that a more complex hydraulic evaluation is likely going to be part of. It might be part of the planning effort as opposed to the design effort, hopefully, right? Though that brings us to an evaluation required by the division, and that's really driven by sanitary deficiencies. So if it is identified that there are widespread pressure deficiencies in a water system, or there could be widespread pressure deficiencies, the division may require a hydraulic evaluation. And hopefully in that discussion, when it's outlined, it'll be clear what hydraulic evaluation is required. And if there are any questions, it should be ironed out at that time. And then the other common ones would be evaluations to support infrastructure improvements and asset management. So specific examples of those would be the hydraulic evaluations funded with the DWSRF monies, and I think 2 IUPs ago, that intended use plan cycles ago, that were 100% subsidy if the hydraulic evaluation complied with the guidance document. And some asset management plans have been required to comply. Hydraulic evaluations within asset management plans have been required. That one is that's not all the time, but it has happened. And those requirements should be hammered out during the engineering service agreement review. Are there any questions about that before I move on to some of the lessons learned as we've reviewed some of these?
I have a question. On the consultant side, are there water systems that are initiating this work that want to know what their pressures are in different locations? Or
yeah, I think a lot of it comes up with deficiencies and it just expands from there.
the other kind of thought I had was that this would be relevant, like for expansions that require pump stations. You know, towns would want to know for development purposes when a pump station would be needed. And I wonder if anybody's gotten questions like that from anybody.
Yeah, yes. And one area that towns are generally interested in is fire flow capability. So, I think distribution system models are commonly done with system planning studies. So if you have a water system planning study to develop a capital improvement plan, whether it's a 2-year, 5-year, 10-year capital improvement plan, really in any complex system, the best way to do it, maybe the only way, but the best way to do it is with a hydraulic model, which allows you to do the what ifs that are necessary really to come up with the CIP. And that's pretty common, a CIP that will allow for expansion of the system, or if there's a big user that's been proposed in town, Or if there's concerns, well, like you said, Willie or Allison, if there's concerns about areas of pressure deficiency, and in particular, areas of insufficient fire flow. So all of that can drive the need or the desire to perform a distribution system, hydraulics model and evaluation.
Kind of dovetailing with that, Dave, is we've seen a lot of efforts to add housing. That seems to be a push pretty much everywhere statewide, and
Yeah,
preferably
but-
not in a flood prone part of town. So moving up a little bit elevation wise, and so we have seen some additional interest there.
it's very rare that an average day demand condition or a max day demand condition, or maybe even a peak hour, truly stresses of a distribution system. It's a large withdrawal, so it's a fire flow. If in England there are distribution systems that don't provide fire protection, and the pipes are smaller. You don't get 8-inch pipes, 12-inch pipes, 16-inch pipes in those systems. So it's really fire protection, generally speaking, unless there's a big industrial or commercial demand. It's your fire protection that really drives that stresses a distribution system hydraulically, and particularly if they have a large downtown area, commercial area where your fire demand may be 2,500, 3,000, 3,500 gallon per minute. That's what's going to stress your system. Otherwise, in typical systems, and I'd be interested to hear from the other consultants online here, but your average day, max day demands are not going to really stress the distribution system.
I agree. At that point, like once the state requires like a fire flow requirement, then that's when you start looking into the EPS, which this is more static, right? So water quality concerns come up at that point, right? But
Oh yeah,
it's just geared towards hydraulics only. Then it's fine. And I don't think your guys' document is more concerned about water quality. That's just going to be something addressed in that ESA.
yeah, and hydraulic models do a much better job of simulating system hydraulics than water quality and distribution systems, even though they have modules that do that. They're much more accurate for basic hydraulics than water quality modeling, typically.
Yeah.
Especially chlorine residual.
What we're finding is this because fire flows kind of drive a lot of the modeling, like those are the largest flows. And that's what a lot of people are concerned about, being able to serve fire hydrants. That's a big part of the modeling. But one of the more simple aspects of it is what are the highest pressures that the water system sees, and what are the lowest pressures? And those are just some of like the simple things that we want to capture for a lot of these water systems. And I think that's those kind of boundaries are what we're trying to drive at a lot with the guidances, making it clear what the boundaries are and what they mean. I feel like that's what we've talked a lot about, Allison.
Yeah, and accompanying that is the velocities that you'll see in some of these pipes, particularly our older distribution networks that may have undersized lines for current build out. If you start pushing 3,000 GPM through a little 4-inch line, you might see some damage happen, or, you know, you get one new person on the fire department who slams that shut, you might see a lot of damage happen. So it's kind of highlighting some of those situations too.
From a fire standpoint, another real benefit of a model is that when you do a hydrant flow test, and then you're interested in what the fire flow capacity is when at a 20 psi residual. Of course, the regulations say, and that rightly so, that it's 20 psi anywhere in the system, or in my opinion, anywhere where there's a user. But when you're doing that hydrant flow test in the field, you may not know at what point in the system drops to 20 psi. Matter of fact, most of the time you won't, unless there's one high point that always drops to 20 psi, and maybe you would station somebody at that point. But so one of the real benefits of a distribution of the hydraulic model is the determination of the fire flow capacity at any point in the system, given the constraint that any other point in the system not fall to 20 psi.
That's actually one of the first bullets in the lessons learned, is trying to clarify expectations around what do you do if you see pressures drop. Like you said, Dave, you might not know until you get back to the model. But there have been instances where we've had hydrant flow test results submitted where it's been clear to the staff flowing the hydrants that they've dipped below 20. And so we would like to do some, you know, clarifying of, okay, it's the consultants, whomever is out there, it's your responsibility to make sure that the system staff are aware, and to do that quickly, because they may or may not be involved in the hydrant flow testing. And then it's the water system's job to do the next step, which is, you know, likely issuing a boil water. Or if it's just this hydrant can't do it, you know, it cannot provide fire flows, then notifying the fire department and, you know, coming up with a plan with us for what to do. If you're going to paint it, what are you going to do with that hydrant? But that has been we knew we were going to see results that were surprising at times, but it's been surprising how limiting some of our systems hydraulics are, that it can be that immediate for some of them.
I guess I have a question. I mean, so for your guys' future sanitary surveys, are you gonna maybe start wanting to require systems to produce a hydraulic model to give you guys more insight before you step into issuing maybe a violation? How are you guys verifying that there's pressure deficiencies when you go do a sanitary survey, other than like what the town's telling you?
So basically what the town tells us, if during the sanitary survey, there have been recent boil water notices due to low pressure, or the operator that's leading the survey says this hydrant here doesn't flow, then that will become a recommendation, maybe sometimes a deficiency in the survey letter to get to hire an engineer and do a hydraulic analysis and figure out which hydrants or which portions of the system don't have adequate pressure, if any.
Okay, so you are looking for, I guess, if you have hydrants that the water operator knows does not provide minimum fire flow, they've already painted it, is that considered a deficiency?
No,
Okay.
no. If it's already been converted from a fire protection hydrant, then that's like there are management strategies. You change the hydrant so that it's no longer a fire protection hydrant. But there may be,
Saying like they just paint the nozzle red.
generally the operations section will want more management than that. Sometimes it's a lock on the hydrant.
Mhm.
Sometimes it's painting the hydrant black. Ukraine group, came up with an idea to weld. Sometimes it's welding the pumper nozzle closed. There's just the 2-inch nozzle. Sometimes,
Yeah.
this idea.
Yeah, we recommend that only so that if it can down the road, get fire protection, place the hydrant again.
Yeah, and then, one idea is to weld an orifice plate over so that it's not a 2-inch nozzle, so it can't physically flow the too high pressure, the too high velocity, too high, whatever, can't physically flow the amount that's too much. So there are management strategies for that situation. No, but often we'll go to water systems and our operations section will do the sanitary survey, and there'll be hydrants that aren't in any way indicated to not be able to produce 500 gallons per minute. And then that kind of starts it. And there are also other places where like a user will complain about low pressure, and we'll learn about that and then ask for a hydraulic analysis.
Right, or it might come up as part of a construction permit application when someone does a Hayes and Williams relationship and goes, oh, I'm not comfortable with this anymore, or a different, a planning report where they, hey, there's 5 users with in-home booster pumps. Something like that. It's generally, they're coming to us. A user or the system are coming to us with the information. We haven't, to my knowledge, required anyone to hydrant flow test or produce one without some kind of indication that there was an issue.
There was a period of time when the division was like requiring updated reports essentially on like total system fire flow capacity per hydrant. There was like there's a little blip. We had to do a yearly update.
Well, that's kind of one thing that I was thinking about is.
It's not encouraging you to do
No.
that.
But, and this is one of Allison's lessons learned points, is that we get reports of this model, like, say it's a modeling effort. We get a report of a modeling effort and there'll be like some discussion on different scenarios run. But what you've done is way so much more than that. And there's so much more information that's really hard to convey in a report, that I think one of the ideas we're talking about is when we need to review a hydraulic model, it seems like the review would be a lot more beneficial, and I wonder what you all think, to like look at the model together and understand, just like in a meeting with a shared screen, what the model's capable of, rather than try and figure that out from a report that might not discuss everything the model's capable of, or all of the, if the report actually only ever talks about hydrant flows and doesn't mention all this other information that's contained in the model. Does that make sense? Have you ever had that thought, like it'd be just a lot easier to walk them through this model?
Yeah, I would say like before any started, just have you guys talk through what I'm gonna do and then have a follow-up during the 30% submission. Answer any questions and then fine tune it. Great.
Guys go through this exercise as far as like standardizing. Allison talked a little bit about at the beginning, like what's required with the different systems.
Well, I think that doing a hydraulic analysis for each one has its own purpose. Simply to do a hydraulic model, that's an exercise. So, you create the model, you do your hydrant flow testing, and you do your calibration. Calibration is a key. It really needs to be, there needs to be a calibration table in the report demonstrating that the model is adequately calibrated, and no system calibrates perfectly. So you have to start asking questions. Why didn't this area calibrate well, or that area, or something like that? But then you have a model. You know, it's an exercise. So then the question becomes, well, what's the specific purpose? What do you have in mind for this particular, you know, application? Otherwise, yeah, you've got a model.
It's another one of my questions, and I don't know what software you use, Dave, but like for a big system and calibration, like what extensive calibration are you guys gonna want to see for maybe like an expansion, right? So if I'm doing maybe a loop section on an existing main or line in like the southern portion of town, you're not gonna want to see me calibrate that whole model just for evaluating a small section of town, because at least with the software we use in the calibration wizard, it would take hours to calibrate, and it would take a lot of field testing for a section of town that's not even applicable to what we're looking at, because it's a different pressure zone. So I don't know if you saw any questions coming with that specific one, but like Dave, I mean, I don't know, like what software you use?
I've been using EPA Net for the smaller systems. But yeah, I agree with that, that there are going to be cases where you just have a specific question in mind. Maybe you're designing a pump station and you want to size a pump. You don't necessarily need a full system model. You can model a portion of the system and be able to size your pump. You know, sometimes we call it a skeleton model, where you don't have all the pipes and everything, but it's sufficient for answering a specific question that you may have.
I think that's a good, like often a point of confusion for us is, are you just starting to make a model, or are you starting with a problem that the model is intended to address, to help you determine how to resolve? So that's sometimes why, like, sometimes we see hydraulic reports that we thought it was just going to be the creation of a model, but then like all these scenarios were run about problems that we don't know if they even exist. And then other times we see like just problems with that kind of thing. Like the most basic example is running the Hazen-Williams, the calculation to put on a new hydrant to do an extension and get like an estimate of what you think the hydrant will flow. But you might also just get like a new pump station and pressure zone, and there'll be a model for that.
There should be a purpose to everything you do. And like I say, hey, a model is a tool. A model is an analytic tool. That's all it is. It's a simulation of a system. And every point in the system has a flow pressure relationship. That's all it is. And you can liken it to where the doctor and the model is the X-ray device. So if I'm a doctor and somebody comes in with a broken leg, I'm not going to X-ray his whole body or her whole body.
Are you doing the time?
Doing what time?
We mention the time.
No, I was gonna let Dave finish this and then I have something I want to say.
Yeah, that's all I'm saying. It's a
Oh.
tool, it's an analytic tool to be applied
I'm not
to
still
a
there.
specific problem or purpose. I'm
Yeah,
done.
thank you.
Yeah, I guess to that point, I don't think anybody's ever come to us and just said, we'd like a model. There's a reason for it. Usually for us, it's, full system evaluation. And I guess to that point, there's sometimes where you don't even need a model. If it's like you said, like the hydrant extension, something minor.
We should check in on time.
Yeah, can I just say one thing? So this is just sort of what I've been hearing is to your question about like what level of calibration is needed. I think if you justify what you want and you explain the context for that, then that that is what we want to see. It's the explanation for why you choose to do X, Y, and Z. It's for us to understand the choices you make in your model decision making and in the results, because just looking at the results without the context of what decisions went into the boundary conditions and the limitations that you're seeing, then we're left with no tools to sort of evaluate what was done. So I think it's really the explanation piece and not so much the actual making the model. It's the everything around that we just need more of. At least that's sort of my understanding from our conversations with the team.
It is 2:02, so I imagine you all didn't schedule anything at 2. But Allison has her hand up, and I would continue talking, but I don't want to keep people who need to do some other things. So would anybody like to keep the discussion going? You're
You have permission to leave.
you're good to keep talking?
Yes.
Okay. That could be.
But if you do have things you'd like to say and you do need to take off, feel free to send an email or put it in the chat. We forgive you for leaving on time.
I think maybe that's the right way to do it. Those that can stay, those that have to leave, that's fair. That's how we expected it.
Yeah.
No pressure.
I was just
move
gonna,
thought sometimes right after Allison, whoever else.
I was just gonna follow up on Sela's response to Nicholas. Unless the division has required the model be developed for a more widespread issue, then I would expect some discussion about the whole model, because it's not clear to us when it was updated last, like our demands updated, or some of the big picture things, and then focusing in on calibration of that pressure zone. And that can be supplemented. I think it's 3 years in the flow tests within the past 3 years for the focus area is what's in the guidance currently. But that we could discuss that further. But generally we want to see within 3 years some kind of flow testing in that pressure zone that you're concerned or doing work in. So not the entire system.
Yeah, that makes sense, like doing the check-in with you or the drinking water division to maybe clarify some assumptions we're making prior to getting model. Because I mean, we've also been in systems with the town where like the south end, like, there's a suction being pulled, that can measure accurately like how much of a suction we're getting. So that really can throw off a calibration. So making some of those assumptions and clarifying with you guys beforehand makes sense, and just everybody work together to get it final product. So, cool.
And Jonathan, did you ask if we had been trying to standardize what type of hydraulic evaluation was required with each situation or each size system? Is that what you had started to ask Willie? I couldn't quite catch it.
Conceptually, yeah, something approaching that, yeah.
We haven't gotten that detailed. However, we've increased communication with other sections requiring hydraulic evaluations to try to create more consistency there of like, yeah, in that instance, we think a hydraulic, like just doing some hydrant flow testing would be sufficient versus that sounds like a more widespread issue. We should talk more about that. So we haven't gotten that granular because it's hard. It's hard to get that granular with the different situations that we see.
Hard to maintain the thread too on some of these things, like maybe a deficiency identified at a sanitary survey and then it's kind of off the radar until an engineering service agreement appears with a loan, like as part of a DWSRF loan application. So like picking up the thread back here and trying to figure out what the context is and how much information is already known about this water system versus how wide, like, is this in a pressure zone? Like, do we even know where the boundaries of this pressure zones are in the water system? So it can be hard to maintain the thread for those kind of questions. And then decide like what is a model appropriate? Is this a small water system? And we just need to know the hydraulic grade line to like figure out if there's an upper elevation that things should be at. You know, so sometimes it's hard to maintain the thread of the water system and what might be needed over the time period that the problem arises and then solution starts to manifest. Did you have other thoughts, John?
Well, yeah, one was timing. I think Allison started to talk about it a little bit, but, you know, and I think I primarily see this, like Tim said, as far as just a comprehensive water evaluation. But just in the whole gamut of when, you know, like you said, you may not get your hands on something until you have a permit to construct application, potentially, whereas, and we're involved on jointly funded projects, right, where I'm seeing engineering reports approved sometimes a couple of years after we've done. So I guess I'm just wondering, ideally, this is done at the preliminary level, I think. So it was just a general comment or thought, like, is timing gonna be considered as part of this? You know, we have the joint preliminary engineering report guide that we've kind of jointly adopted. How does that play into that? But yeah, generally, just the timing aspect. Is there gonna be any sort of guidance on that? And will it sort of hopefully push it towards a preliminary level?
Yeah, I mean, we'd like to see, it'd be a lot easier for us if we had as many water systems as possible with some kind of hydraulic evaluation. Like whether it's a model that an engineering firm takes care of or a system map that just shows the upper and lower elevation boundaries of service area and pressure zones. So the more of that information we can get on the water system, the like easier the timing goes on that. And Allison or Nathan, you may have a sense of this too, but my sense is that the hydraulic evaluation is different than the preliminary engineering report. And a lot of cases you need to do it so that you can evaluate alternatives that you're talking about. But like reviewing the hydraulic analysis itself it has to be different. We've never had any luck when they're like the same or they come in at the same time because it gets confused about what each planning document is doing. The hydraulic analysis is just informing your alternatives selection. So when it comes to hydraulic analysis, we want them to exist and be used as tools, like Dave said, versus like being something that's part of a planning, or like an engineering report or alternative.
We've had
And
a few, oops, sorry, thought you were done.
Go ahead.
Sorry.
Yeah, I'm done. Yeah, go.
We have had a few lately, especially with the 100% subsidy that came through a couple of years ago that were incorporated into PERs. Those ones have been prioritized due to the systemic nature that was either suspected or known. I believe they've all been at least reviewed once, the ones that have been submitted. So we've tried to like not throw the timing off just due to workload queues, kind of, to try and keep it in line with USDA and just DWSRF a little bit more. But as Willie said, it has been very challenging because there's a lot of technical meat in the hydraulic model report that isn't necessarily for the audience of a board. Like some of it is written for us to review. And so it's hard to fit into the format 1780-2 in a way that keeps it readable to present at a council meeting or something like that. So we have seen consultants put them into like hefty appendices or like split it up in that way to try to keep it somewhat like it's an integral part of the PER, but somewhat separated to not mess with the format, the agreed upon shared formatting. But yeah, it is harder to do timing wise because they're beefier. PERs are with that kind of with a good hydraulic model report there's more to review.
Yeah, to that point, so we have a calibration report, what we call it, which is full development of the model calibration. Are you suggesting that maybe that gets submitted separately ahead of time?
It might make sense. Like Willie might be able to answer that better. Those few PERs that, I think we've dealt with the ones of quite a few of them that were wrapped into the PERs, but maybe Willie can take the approach for the future.
Yeah, I think the fact that we tied funding forgiveness to the creation of a hydraulic analysis for a certain number of projects complicated our timeline on it. Because then you've got water systems that have problems that needed this hydraulic analysis created for it, and now we're spending time like talking about making sure that reviewing that the hydraulic analysis met our funding reimbursement requirements. So that I think when they're not tied together like that, then we're just gonna have fewer comments on the hydraulic analysis itself, like the specific calibration report or document. So I think that's kind of one of the challenges we've had internally is when we've tied it to funding, like we've introduced another level of review for ourselves.
Well, the PER format doesn't fit this type of project anyway, with the 100% funding, that program. The PER format seems to be set up where there's a problem, you evaluate alternatives, and then you come up with a solution. That's the way, but the projects that we've done under that grant program is you create the model, explain it, show how and then evaluate the system to see where the weaknesses are. So it's not a problem statement, evaluate alternatives, pick a solution. It's evaluate the entire system, see where the deficiencies are, and recommend solutions. You may have one deficiency, you may have 3 deficiencies. You may need a bigger pipe here, or more storage in this area. So the type of project we're talking about with modeling and doing a system evaluation doesn't fit the PER format at all. So, in the ones I've done, I've built the model description and discussion into the body of the report. But it's really a misfit from the get-go.
Doesn't it depend on why you're doing the model to begin with, right? I mean, you could have, but I don't think that's exclusively true. I mean, you could have some problems in the system known without modeling. And then through the process.
Yes, oh yeah. The systems know where their problems are typically. They've had customer complaints about one thing or another. The people the operators know where the problems are. The question is, well, what are the fixes? What's the most cost-effective, fix to address those problems or fixes?
Right, and that's ultimately the point of the PER. So, you could just be doing a model for, not as part of a capital upgrade. Or maybe through the process of modeling, it results that you realize you have some deficiencies you should address. Often what I see is, like was mentioned, fire flow is kind of often the biggest factor in modeling, and it's often going to be the biggest factor sometimes in upgrades, like tank location, tank sizing. And we get PERs that recommend 3,500 gallon minute flow for a 50,000 gallon a day system, So I'm interested it's maybe kind of an offshoot, maybe there shouldn't be as much time spent on it, but, we did talk about fire flow and the importance of how it figures into modeling. And I think so I guess I'm wondering about that as well. I forget whether you guys have guidance. I think you do. On fire flows and storage.
There's very
But it goes
little
back to
information.
inputs, right? Your model's as good as your inputs. So you're running scenarios at 15, 25, 35. How are we getting to this?
Typically,
Are you asking whether we have guidance beyond the water supply rule in terms of how to set it up to model fire flow, or?
It was just kind of an open rant.
Okay,
Yeah,
Yeah.
go wherever you want with it.
yeah. To my knowledge, we don't have anything in particular written up. It is sort of what the water supply rule. But I think that is often the questions that are going back to the consultant is like, how did you model the storage level to show that there's enough fire flow, for example? So like, tell us a little bit more about the conditions around the model input to show that there's enough fire flow.
first of all,
But guidance more than what's in here.
First
We
of
don't
all,
have to.
there's very little, water regulations don't address fire flows. Now, Vermont's a little different because you have a 500 GPM minimum. The Federal Safe Drinking Water Act says virtually nothing about fire flow. Says you should have 35 PSI in the system under normal conditions and 20 under fire demands. The Safe Drinking Water Act and most regulations for states are completely aimed at water quality. That's one thing. Now, as far as fire flow goes, there's a flow rate and a duration requirement. Allison, one source of information you didn't mention was AWWA Manual M31, which is distribution system requirements for fire protection. And that does talk about duration, which goes to the size of your tank, plus the size of your pipes, and also talks about residential fire demands, depending on how far apart the homes are. It goes into a lot more than that, but I found those two things to be useful. But again, as far as us consulting engineers do not determine the fire requirement. Okay. If you have a hotel or you're putting in a Walmart, big box store, we do not determine the fire flow requirement. The municipal engineer doesn't do that. The municipal engineer determines what the system can furnish, flow and pressure. It's up to the fire protection engineer or the fire chief in many cases to determine the requirement, or ISO, but we can talk about ISO. Those aren't really requirements, but they're goals. So the question becomes for us, how do we determine if the fire flow is adequate? And in the absence of somebody telling us how much is needed, like a fire chief or a state fire marshal or a fire system design engineer, to be honest, we kind of wing it based on experience. But again, when we do a model and we're working for a town or a city, what we're determining is the availability of fire protection, not the requirement.
Jonathan, too, how a system or slash consultant might pitch fire flow to us, I think is a little different. How they might pitch it to you, just because of the funding, the eligibility criteria for DWSRF funding versus USDA RD funding. We often get kind of stuck in this kind of awkward position of trying to figure out eligibility based on precedent, DWSRF eligibility criteria, and existing system capabilities. So it'd be interesting to talk fire flow with you to try to make sure that if we can simplify our approach, that would be helpful. Because as you're right, Dave, that I didn't mention M31, and it's because the water supply rule specifically references ISO and the minimum and the discussions with the fire.
But those aren't. I'm sorry, I don't want to hog the situation. As you can see, I can talk about this for a while, but ISO does not establish minimum flows, and they say that, and I can put it up on the screen, but I'll read it from one of the reports that they did. The above listed needed fire flows is the term they use, are for property insurance premium calculations only and are not intended to predict the maximum amount of water required. So ISO does not determine, they're a guide, and we often use them. But you'll see ISO saying, well, we need 6,000 GPM here or 7,000 GPM here. And no, very few systems are going to be able to provide that. So it's a guide, but don't treat it as minimum requirement.
This only matters if we're running this dynamically anyway, so right? Or
No, not to.
Right.
I have to jump off. I enjoy
Yeah,
this.
so the 1 week here with.
Yeah, I think this was really nice to have like an actual conversation around it. Before you jump off, Dave, and before everyone else jumps off, I just want to just loop around with what Allison started out with, is basically that this hydraulic evaluation is in a draft form, and the goal is really to move it out of its draft form and just say this is the hydraulic evaluation. So I'm just curious, now that we do have a couple of folks in this room, are we close? Are there anything we should be thinking about changing in terms of moving this from its draft form to its final form? Anything that we can address here and now, or of course in a follow-up email if needed?
Yeah, I had two comments, and I don't know if it needs to be discussed now, but things to think about. So under the, I guess, part 3, reporting and documentation under testing, I was just curious, and exactly that would be required and what would be required. Because often we are building a model for a full system. I don't know if you need a list of exactly what we're doing. Oftentimes we have spelled that out in our scope. But you guys don't have to. Sometimes you don't see our scope. So just curious when that is required. A lot of those, for the full systems, we're following M32 industry standards. selecting, test locations and what information we're gathering for storage tanks and pumps. And so I was just curious what's really needed there.
Okay,
And when it would need to be submitted to be reviewed. And then my only other comment was, I think it's toward the end of the document, there's discussion about calibration and being calibrated when you're in 5% of results. And percent is a little problematic. Because it's percent of what, and if you're a hydraulic grade line, or your grade line, or you can be off. So, he looked M32, which, I think it changed at some point, but it's now saying within 5 to 10 feet grade line. So it's a value instead of a percent.
okay.
So, Tim, that doesn't apply to the grade line, that calibration bit. It only applies to the model as written currently, or as we intended it to only apply to the model. But that's interesting that the upgrade, you said the newest version of M32 is 5 to 10 feet?
I know the latest is 5 to 10 feet, and I do think it changed at some point.
It's not really related to the grade line. It's related to the drop in pressure. In other words, if you flow a hydrant and you drop the pressure 10 psi and you model it and you drop the pressure 9 psi, that's a pretty good match, but you're still 10% off. The calibration of the model is to calibrate the pressure drop caused by a certain flow rate. And I got to jump off. Thanks. This has been good. I enjoyed it. I enjoyed talking.
Thank you.
Great, thank you. Well, thank you. That's great.
Yeah, I mean, he's correct, but even if you're looking pressure, doesn't make sense to look at a percent. You're starting with 100 pounds versus 20. Your error band just changes. The error band should be consistent with what.
The way we've typically seen them presented is the hydrant flow test result versus what the model predicted at that location under those flow conditions. But I see your point, Tim. The test plan, just briefly, part of what we'd like to expand upon there a little bit is if there are no fire hydrants. We've had hydraulic evaluations submitted on systems that do not have fire protection, that do not offer fire protection. And it's varied from no calibration proposed to multiple pressure recorders and other measures to try and calibrate. So we'd like to clarify that a bit too. So timing and what's involved.
Nicholas, did you have thoughts on calibration?
No, I think I just had a general question about like seeing the drop in the hydrant. I've never seen that before. I can't remember which section that is. Is that just from the
Yeah, so M32 recommends when you do a fire flow test that from your residual hydrant, you get a 10 psi drop. I'm not sure exactly what he was referring to, but that's the right.
and residual hydrants, not the, like we're talking about a hydrant separate from the one we're following. And it's just not at
Yeah,
the
and it's really to try to get as much drop as reasonable.
some like yeah, I mean I guess some municipalities maybe don't like to just let that thing rip because they want to put a flushing box on it or something. So you can get into an argument with an operator saying he doesn't want to like flood somebody out or wreck somebody's yard. So I mean we're going to be constrained sometimes, but I think again that's just the conversation we're going to have beforehand. Make sure we're all on the same page. So I guess I don't have any other comments other than Size,
Yeah, that's
they're all,
true too. I mean, number of systems, even on a 12-inch main, it's like trying to, you know, generally not trying to do a fire flow on a new main for a model, because you know that condition, but there's some situations where it's like, we'd have to open 3 hydrants and nobody's gonna do that.
yeah. So, yeah, I mean, as long as there's clarification, some of these things we're just gonna talk about beforehand.
All I would say is, this is a guidance document, right? So this isn't gonna get baked into the rules.
Well, it's a good baked into the rules, but it does get baked into the essays. And in that case, I will be looking to see like, well, you said you do this work, so did you do this work?
Oh, yeah, no, I think what we're discussing though is like the fact that all of us have to exercise discretion. And so I think the important thing, I think it's, always important for us to know where these things are different. But we just acknowledge that this is guidance. We're gonna try to work, inside of these guide rails, but that we're gonna be dealing with unique conditions so that we can be addressing whatever problems or issues.
Yes.
Yeah, and sometimes you're not gonna be able to calibrate the models like satisfactory to yourself. And there's gonna be some unknown that you don't have the scope to go find out. And so in that case, that's when the explanation Celia was talking about was like, we didn't figure out what was going on here, but something is going on.
Right. We flow tested twice and checked for partially closed valves and couldn't find it. So it's beyond scope, but just telling us what you did. It's really helpful.
Yeah, I'm gonna
All right.
call it here. But thank you for joining us. I hope we didn't keep you too long. Maybe I'll work in an extra half an hour for discussion beyond in the future, but.
It was really nice that you came in person.
It was.
Yeah.
We want to do more of these analysis separate from engineering reports. And this is just like part of it. We've always, Allison and I have always talked about this because when we see it from the operations side, there's just no information about so many water systems. Like we'll get questions from our operations section and we'll go look at the water system. We're like, well, we don't know where, if it's in this pressure zone or this pressure zone, how many pressure zones there actually are. So just like the most basic information that's like where we're at. I know that you are all working on more complicated models most of the time. So it's good to know like your perspective, but you also come across water systems where they don't know where they can serve water to. And we would love to have that information. We'd love to, before we go on a survey, have a map of the pressure zones and know what kind of like where there's high pressure and where there's low pressure and where there is storage serve pressure and where it's all pump station provided. Like that is not information that is easily accessible, not information that water systems themselves always know.
Yes, you're using your RTCR sampling plan. Oh, okay. So you have 4 pressure zones based on where you sample.
Yeah.
Thank you.
Alright. Yeah. Alright, I'm gonna.
Thank you, Allison.
Yeah.
Better.
Yeah,